Hi, good afternoon, and thank you for joining us for today's webinar. My name is Maggie Sweeney, and I am the Executive Director of Washington Defense Trial Lawyers. And today's topic is transportation safety, human factors, and biomechanics. I am joined by Dan Palac and Zdravko Salipur, and they are with Brilluin. Brilluin. Dan, say it again, Dan.
It's Berlin.
Berlin. There we go. I got a lesson on Berlin. Apparently it's French and it's very scientific. And if you say it a few times, it will roll off your tongue. I had it earlier, but I'm just going to leave it to the true experts to keep pronouncing that. But looks good. And I'm just going to keep working on that. Okay, so thanks everybody. We're looking forward to today's presentation. I'm going to go over a few things and then turn it over to Dan and Zdravko. First, if you are joining us by phone, please email me, maggie@wdtl.org, and I can make sure that you get added to the list for attendance and CLE credit. If you're here joining us online, I can see your name and you do not need to email me. We are approved for one CLE credit, and I will have that entered for you in about 30 days or so. If you have questions for Dan and Zdravko, you may use the Q&A tab. Many of you, we've gone through this before. It's the little box with the question mark. Type in your question. This is a packed webinar today, and I know there's a lot of content, so they may not be able to get to your questions until the end, but please plug them in there if you have them. There's also follow-up with our experts available after this. I want to remind people that next week we have a CLE on Wednesday. It's by Dr. Brown and it's sponsored by McCann, so consider joining us for that. Our annual meeting is July 23rd to 26th at Skamania in Southeastern Washington. We would love to have you with us for that, so think about that. And you will be getting an email soon regarding our government liability committee. We are kickstarting that committee because so many of you are now dabbling into government liability, and we want to make sure that we are, WDTL is providing adequate support. So with that being said, I am going to turn it over to Dan and Zdravko, who are going to enlighten us regarding transportation safety. Thanks, guys.
Great. Thank you, Maggie. And thank you for hosting us, WTDTL, for again letting us talk a little bit more about who we are and the topic of transportation safety. So I'm Dan Palac. We also have Zdravko Salipur here. We are from Berlin. We're an engineering and scientific consulting firm. We're the Berlin itself is newer to the field, but all of our experts have years and years and years of experience. And many of us, again, have been doing this for decades. So I'm a human factors expert. Zdravko is biomechanics as well as human factors. We're going to talk a little bit more about our backgrounds here shortly, but again, the title here today of our presentation, Transportation Safety, Human Factors and Biomechanics Approaches to Incident Investigation. Disclaimer slide here, just making sure that we're not redistributing these slides without our permission. Got to have that in there as a formality. And so today's roadmap, again, we're going to start with introductions from both myself and Zdravko. And then what we like to do is give a little primer on our area of expertise, talking a little bit more about human factors. And then Zdravko will talk a bit more about biomechanics and really what that looks like in the transportation space. And then hopefully we have enough time to cover two case studies. Again, one from the biomechanics perspective that Zdravko will cover, and then we'll end with a human factors case study. So we will start with introductions, and I'll turn it over to Zdravko.
Thank you, Dan. Thank you, Maggie. It's a pleasure to be with you guys this afternoon. And before we get into the kind of the presentation, I was very pleased to see that we were able to schedule this before the kickoff of the World Cup. I was a little afraid that with the World Cup starting tomorrow, I guess, we would be competing with not just work but also other things happening throughout the day. So As far as my background's concerned, let's start off first off with my name. I know a lot of folks that I meet, and I've worked with attorneys. I've worked with some of you, I think, in the past, or at least folks from your firms before. I look forward to doing so again. But whenever we get into it, the first thing I have to kind of explain is my name. It's very difficult to pronounce, and as the company was founded by Steve Murray and Rodrigo Perez, I've told them that I will join, but I will only join if the firm name is equally as hard to pronounce as my first name. So with that, as we work together, I hope to kind of help you on the pronunciation side of both the firm as well as my name. Little background about myself, just so you know where I come from and why I am qualified to educate you on this topic. My education background is mechanical engineering with an emphasis in biomechanics. Basically, my master's and my PhD had a focus in biomechanics, both at the thesis and the dissertation level. Prior to joining Berlin, much like many of our colleagues, I have worked at other name brand engineering and scientific consulting firms, namely Exponent. Dan's also former Exponent. Our firm has folks from former Exponent, former ESI, former Rimkus. So as we start to work together, we hope to show you that while we may be working under a different banner, you'll still be getting that A team on your file, and you'd be getting sort of a boutique experience, and that's why we think our firm is a little bit different than the firms where we came from. Um, Speaking of firms we came from, prior to Berlin, I was at Exponent, and I've done a bunch of different work in many different areas. I'm an experienced testifier. I've testified in an array of different litigation matters, ranging from patent litigation, product liability, premise liability, and I've done a couple of workups on criminal cases, even although I've not testified in those. I have over 2 decades of experience in biomechanics. I've also done a bunch of work in the user experience lab when I was at Exponent, which kind of allows me to bring a novel perspective when handling these files. So this user experience lab was one that dealt with non-litigation engagements. So think of manufacturers engaging scientists to help them answer health and safety questions and design questions. So that sort of non-litigation experience allows me to kind of look at a file with even another set of eyes from a usability perspective, and I'm talking about disuse, misuse, those sorts of things. I also have a bunch of experience with human subjects evaluations and as well as mechanical testing, computer modeling, a bunch of other things. And I also, after I left Exponent, I was at a firm called Axis Consulting that you may have heard of in both Arizona and California. And I look forward to meeting some of you guys as we hopefully work together so we can help you on those files. Dan?
Great. Thanks, Zdravko. So a little bit more about my background. I completed both my undergraduates and doctorate degrees from the University of Illinois at Urbana-Champaign. Physically, I'm located in the Midwest here in Chicago. My degrees and really my area of study pertains to psychology and graduate work in cognitive psychology. My thesis involved a three-group physical activity, cognitive training, and combined approach, and looking at physical activity, the effects of that intervention on symptom reduction among individuals diagnosed with post-concussion syndrome. So I was looking at a lot of cognitive predictors associated with physical activity as well as that cognitive training program. And so spent a lot of time studying theory of behavior change, as well as physical activity adherence, and then obviously areas of executive function as a result of those interventions. Following my education, I jumped into the consulting world and worked at Exponent, as Zdravko mentioned. I was there for about 6.5 years before joining Berlin last fall, where I did a lot of work again in the human factors practice at Exponent. A lot of the same work that Zdravko was describing in terms of user study research, a lot of UX work. And over my years as a consultant, I've helped clients handle issues related to product work as well as operator behavior in different contexts, whether that's on road vehicles or while operating different industrial pieces of equipment. So think forklifts, for example. I've done a lot of investigations into workplace incidents, as well as looking at safety information and warnings. I'm going to spend a little bit of time today talking about that area, warnings and safety information, and really what goes into that work. I've experienced testifying in the transportation litigation space, as well as product and premise liability litigation. Again, done a lot of work in the evaluation of warnings and safety information, accompanying a wide variety of consumer products as well as industrial equipment. I've assisted on consumer product recall investigations, and then I've had the privilege to present my findings as the lead HF consultant to the USCPSC. All right, so that was our introduction. We will jump into the human factors primer. Some of these slides I might go through a little more quickly, just in the essence of time to make sure we cover everything. But to jump off, I like giving a little background on the history of human factors. I think it's obviously, I'm biased. I think it's a fascinating field. And I think it's a field that's less well known, especially in the engineering and science consulting world. So a little background here, it really can be dated back to the late 1400s with Leonardo da Vinci's Vitruvian Man. And this gets at the idea of anthropometry, which is the study of the human body's physical properties. And so Leonardo was obsessed with the human body as it as it moved through different spaces. And so he spent a lot of time researching and studying, again, the way the body can move. And so what this looks like today is there's a bunch of different databases out there on human dimensions. And so the example I like to give is, at least in the product space, if we're concerned with like a pinch point, for example, we might rely on data that pertains to the 95th percentile of adult males' index finger circumference to see if it would fit in that severing moment or that pinch point of the product. And so that's all anthropometry. It's certainly a subset of human factors as a field. If we fast forward to World War I in the early 1900s, we're starting to see a lot more emphasis put on the training that we were delivering to combat personnel in World War I. So we're actually focusing on, how we're preparing individuals for warfare, and again, the training that we were giving to them. And then if we fast forward to World War II, we sort of see a shift in terms of the emphasis placed on the training on individuals and more so on the design of aircrafts. And so this pertained to, control placements, color coding schemes in the cockpit, of again, where controls were placed, how easily accessible they were. And this was important in emergency situations so that the pilot was able to depress controls and gauges as quickly as possible, again, in those time-constrained situations. And then 1957, we see the establishment of HFES, or Human Factors and Ergonomics Society. So this is really where we're starting to get our legs as a scientific discipline. We're starting to see research being published and conducted, different journals coming out. And then through time, we've seen major cultural events that have some ties to human factors. And so we have the Space Shuttle Challenger disaster in 1986, which I'm sure we're all familiar with. But NASA had consulted with an outside engineering group that actually warned them against the susceptibility of the O-ring seals and their failure in extremely low temperatures. For various reasons, this warning, this safety information was overlooked or bypassed by NASA, and of course, we know what happened after that. And then again, in more modern day era of human factors, we see a lot of emphasis put on the organization, so the workplace culture, and really starting to emphasize safety over productivity. And that's sort of been the main theme in modern day HF. So, to keep moving forward here, how I've conceptualized human factors throughout my career, my studies, it's the study of the capabilities and limitations of people as they interact with their environment or their surroundings. It's perception, us taking information in, and then that influencing our output or our behavior. Primary goals of human factors as a field is to reduce human error, increase productivity, and of course, enhance safety. In terms of failure analyses, we usually look at it as from three different perspectives. So we look at it from the individual perspective or group of individuals involved in the events leading up to that incident. We'll look at the environment, so where this incident actually took place and the different factors that might have contributed to the incident, and then the product itself. So if it involves a product, some sort of interaction with equipment or machinery or vehicles, we're going to want to look at that role in the incident as well. So I'm going to spend a little bit more time here talking about each one of these. Excuse me, beginning with the individual. So some important human factors here on the slide, starting with memory and information processing. Um, what information was available to the user or the individual or group? And what did they do with that information? Did they even read it? Did they seek it out? And if they did that actually change their behavior? So their ability to process that information and then make decisions on what to do about it, very important part of that process, that investigation. In the context of motor vehicle accidents or transportation, attention and distraction are two of the bigger players. There's a lot of work that can be done in order to determine whether or not the operator was attending to their environment or if there was evidence of potential distraction. Oftentimes, we see that in the format of mobile devices or children screaming in the back seats or something pretty is out on the outside of the vehicle and they're looking at that for some time before they, unintentionally hit a hazard in the roadway. There's a bunch of different ways that we want to investigate and determine what the attentive state of the operator was. Vision, hearing, very important factors as well. I like to give the example of backup alarms. Again, this is more so in the industrial equipment space. So whether or not, for example, a forklift was equipped with a reverse alarm and just how loud that was, there's ways we can measure those sound levels to see if it reaches the threshold of noticeable difference, which is about 10 decibels greater than the background noise or surrounding environment. And therefore have the person use that as an auditory cue in order to avoid being backed over. Strength, dexterity, reach, all again important factors. One of the first cases I worked on as a consultant actually had to do with looking at children's reach, and this was in the context of unfortunately furniture tip over events. And so our client was interested in determining dimensions of their pieces of furniture and again, how far children between certain age ranges could actually reach for whatever it might be that's on top of that piece of furniture and then potentially have that tip over if it's not secured. Movement errors, so think unintended accelerations in vehicles. We'll look at those cases, and then human development, reaction time, expectations, common knowledge. Again, all factors that we'll want to look at and investigate as it relates to an incidents. And so, case study I'll give later today is a good example of perception response time. All right, moving on to the environment, especially in the transportation space, this is crucial. We're looking at factors such as visibility or sight lines that the operator or driver might have had to that hazard. If it was a pedestrian in the roadway, we're also going to want to consider the pedestrian sight line or visibility towards vehicle traffic and what that looked like. Glare, so was glare an issue based on the time of day and the sun positioning? Everything, we can look at in that in order to determine was this discomfort glare, was this disabling glare? And again, would you expect that to, what effect would that have on the operator? Lighting conditions, so a nighttime incident is quite different than a daytime incident. If there's ambient lighting in the background or in the environment, there's ways we can quantify that too to see if it was sufficient in order for operators or whomever to detect potential obstacles or hazards in their pathway. Weather conditions, roadway marking, signage, behavior of others, training, these are all other important environmental factors as well that contribute to an incident taking place potentially. Moving on then to product. Again, this is in the general context of an HF analysis, but product plays an important role. So the vehicle that the person's driving, what sorts of safety features might have been equipped with. More recently, we're seeing a lot of failure to equip claims in these cases in terms of like automatic emergency braking or forward collision warning. If it's offered on one line of your vehicles as the OEM, why isn't it offered as standard equipment on all of them? And so we'll look at the individual's interaction with that sort of product. We'll also look at, just the overall design of it. We'll look at applicable standards and regulations to make sure that that's consistent with or compliant with anything that it might need to, in terms of regulations that provide guidance on that product. We'll look at instructions for use and warnings that accompany the product to make sure that those hazards are warned against. And then specifically, does the safety information do an effective job of identifying those hazards and how to avoid them? Looking at recalls is also an important part of this. Looking at the product as part of an analysis investigation too. More specifically, in the context of transportation, NHTSA actually did a really interesting study about 10 years ago now, though, where over the course of 2 years, they investigated well over 2,000 incidents all across the country. And what they wanted to do was identify the causes of these incidents. And so what they found was their data that 94% approximately of the incidents could be attributed to driver error. And if you boil that down a little bit further, the driving factor of driver error was their attentive state. So a lot of these incidents had to do with somebody becoming distracted or, again, lacking the attention needed in order to avoid that incident. And then, less. Less commonly seen as causes of these vehicle accidents were the vehicle itself. So think the braking system failing or a flat tire, and then a low percentage as well was the actual environment itself, or so roadway conditions, snow, rain, anything like that. It was less likely to be the cause.
Dr. Palac, I have a question. Can you go back to the last slide for a moment? I, you're showing somebody drinking a cup of coffee, operating what looks like to be a cell phone while also operating a motor vehicle. Is this not okay?
Yeah, no, I would not recommend that. And so a lot of times in the heavy trucking industry, if we have driver-facing footage as well as forward-facing footage, that's great evidence that we can use to ascertain as to whether or not somebody was attending to their driving task. It's evidence to support such. And so that's not something that we'd want to see if we're representing the driver. But yeah, I would not recommend multitasking like that while operating a vehicle. Okay.
Oh,
Thanks, Zdravko. So the next kind of group of slides here have to do with warnings and safety information. Again, it's a critical piece to a human factors analysis in most cases, and so I think it's important information to cover. And so the next half dozen or so slides will pertain to this. But why are warnings important? The goal of warnings improve overall product safety by changing the behavior of the exposed individual or organization who's capable of reducing their exposure and increase the overall safe use of a product. And so changing the behavior is the critical piece here. It's one of the hardest things we can do. As a trained psychologist, again, I spent a lot of time studying theory of behavior change. And this was in the context of physical activity, but it's very similar in terms of warning and safety information, is actually eliciting user behavior change. Again, the goal is to reduce exposure to product liability litigation on the basis of defective product and failure to warn claims. Definition of a warning, it's information about a possible negative consequence or message that something undesirable may occur to someone or something as a result of taking or even failing to take some sort of action. And so warnings on product decals, they come in all shapes and sizes, but a lot of them have the same underlying themes, and that's that it's conveying information about these negative consequences. So you see them all over your environment, whether you're aware of it or not. Again, the purpose of warnings, we want to change the behavior of the product user in order for them to avoid injury and again, increase their overall safe use of a product. And so I like giving this example here on the slide of these two warnings, or again, on product labels. You'll see these if you have a water heater at home, something similar is what you'll see on it. I think they elicit a rather visceral reaction if you were to observe these just based on the pictogram there that's available. And so, yes, there's written statements, but really what kind of grabs your attention here is the fire, the individual there being caught in it. And so it's conveying the message that, having open containers or flammable vapors near your water heater risks for fire and explosion. And so grabs your attention and hopefully motivates you to read that additional information. The other one, too, includes a really effective pictogram indicating the hazard associated with the water temperature setting that's on the heater and making sure that that's adjusted appropriately. Now, there are some potential costs of overwarning. A question that I'm often asked is, why don't we just warn about everything? And that's really not, realistic. And if you do overwarn, you're risking reductions in the attention available for other warnings, the salience and credibility of other warnings, and then obviously the perceived importance of other hazards that might not be warned about. And so, another picture I use to kind of get this message across is a picture of a kitchen and every appliance in the kitchen being loaded up with warnings because there's a lot of safety information that goes with a refrigerator or an oven or a microwave. And so there's also the aesthetic appeal of products and that users don't want to see something, quote unquote, ugly that's loaded with labels and safety information that takes away from the aesthetics of it. And so that's always something that comes in up and it should be considered, especially with product manufacturers and how they want to present this information. But it is important that we are getting across, the most important hazards to warn about. Factors that affect user compliance. So there are some costs to the user. These often look like money, time, effort, and comfort. I like giving the example. This isn't necessarily in the context of safety, but we have my wife and I back home a rather expensive Dyson vacuum, and we got a little 2-year-old who is obsessed with vacuuming. And rather than using his own toy vacuum, he loves to use ours. And so we're weak parents, and we give in to him, and we let him play with it. And in doing so, he broke the roller head of it. And in the manual, you will see part of the safety information is that you're only supposed to use Dyson branded products or replacement pieces. And in order to save some money, I decided to buy a similar roller head on Amazon for a tenth of the price. And when we used that, the vacuum essentially became ineffective. It was not, the suction was not what it used to be. And so it's not necessarily in the context of safety or a hazard per se, but we ended up just buying the Dyson branded roller head eventually and spent more money than rather just complying with the information in the manual and just buying the Dyson replacement part itself. Perceptions as well of the hazard, the likelihood and severity, their own knowledge and skills in the environments. These are also factors. I see this a lot in the industrial workplace investigations where think control of hazardous energy. Somebody who's performing maintenance on a machine rather than walking across the warehouse and getting the lockout tagout materials and following that protocol, they think, oh, I'm just going to be real quick. I'll be in and out. They might do that and they might do that a few times and nothing bad happens. And so it sort of builds up this idea of habituation and affordance perception that they can not follow that protocol and they'll be okay. And then for whatever reason, the next time they do that, somebody energizes that piece of machinery and that individual, instead of, having it locked out and tagged out, they're now injured or even worse. And so those perceptions are an important piece of user compliance too. So what do we include in a warning? Again, one of the more difficult aspects of warning developments is answering this question. And so we need to make decisions about which hazards we do want to warn about. It's usually those that might be most prevalent or those that have the higher degree of injury associated with such. But this is one of the more challenging aspects of deciding what to include in a warning. And so there's ways we combat this and approach it. And so you can start with reviewing standards and regulations. A lot of products will have information, safety information warnings that are mandatory. So the FHSA for like paint can containers offer guidelines on what needs to be included, specific warnings and danger statements that need to be on that paint can label. So starting there is a good place. If you don't have, applicable standards or regulations, you might want to look at incident data. So making sure that those incidents that might be most prevalent are ones that we are starting to warn against. If you have a new product, you can look at similar products, competitor products, to see what they're warning about. There's also what's referred to as the NICE database. It's NEISS, and it's a CPSC run database that is open and free to anyone to access. And you can run queries on any sort of product you can really think of, and it'll populate all sorts of incidents that are associated with that product's use. And so that could be a good baseline to see, how people are interacting with the product and how they're getting hurt in using it, and making sure that we have safety information specific to that. You want to consider behavioral impacts of the message that you're including, and then selecting potential messages, generating those materials, and then performing developmental research. So there's an approach to assessing the comprehensibility of your warnings, especially if they have less written statements and are more reliant on pictograms. ANSI Z535 has a substandard that offers guidance on how to do this. And this is great too, because if you have a product that's being used in different cultures that maybe not everyone speaks the same language, and you want to be more reliant on a pictogram, and you want to make sure that that pictogram is conveying the message it's supposed to. You want to make sure that it's being comprehended by that group of users. And so there's a way you can test for that. And so doing that confirmatory testing and then obviously finalizing that label. Last slide here on warnings. And so to kind of sum it up, in order for a warning to be effective, a lot of different steps need to be met. And there's been a ton of research conducted in this area. And so the warning has to be presented, has to be available to the user. They need to then notice the warning. It should be, highly conspicuous. If it can use certain color codes associated with or consistent with ANSI Z535, that's what would be recommended. They need to then read the warning, be able to understand it, and then also able to comply with that warning or safety information, whether that's physically, mentally, emotionally. They need to be able to comply. And then most importantly, and the most difficult, step in this process is they have to be motivated to comply with the warning. So motivated to change their behavior in order for it to be consistent with the safety information. Okay, because this is a CLE, we need to have some case law in here. And so this is just some case law examples in the transportation space. I'm not going to spend a lot of time on this slide and go through each one of these, but these are some of the more relevant cases that have come up. That Matasetti versus Apple one, there were claims that Apple should have designed its cell phone with technology to disable it automatically when the owner was driving the vehicle. That was dismissed. Another interesting one is that last one, Taylor versus Mitsubishi. So claims that because there was no audible backup alarm on the forklift, we had this incident when in reality there were a bunch of other visual cues available to the plaintiff, the pedestrian in this case, that this was avoidable even without the backup alarm. So there's some case law that folks can look into. All right, with that, I'm going to turn it over to Zdravko.
Thanks, Dan. And we've kind of talked about human factors so far, and now we wanted to switch channels a little bit and talk about biomechanics. I'm often asked by attorneys, especially those that may have not used both a human factors expert and a biomechanist on the same file before, kind of how the division of labor is handled or should be best handled. And the way that I conceptualize it is, human factors is a field that can help us with some answers of what happened right before impact. So these are things where an individual, as Dan mentioned, may have been distracted or had visual occlusion, or there might be a plethora of different issues to consider that are kind of driver focused, but all of those are before impact happens. Biomechanics, on the other hand, is going to deal with what happens basically at impact and probably a little bit beyond the impact. So in that spirit, let's talk about biomechanics, and let me talk about the kind of the definition of biomechanics. So basically, what we're talking about is the application of the principles of engineering and physics to the human body. We're going to treat the human body like an object, and we're going to look at the various, say, forces that would be applied to certain body parts in certain set of circumstances. So in the example I'm showing here, basically have an individual who is in a car crash. He's moving forward, and the claims may be, well, I got some spinal injuries. What we can rely on biomechanics to help us with is help us treat the human body like an object, so we can do some engineering calculations and an engineering analysis and quantify what these forces are. And we'd even take it one step further and then compare what those forces are to other activities that I would refer to as activities of daily living, such as lifting a box, or as I show here in this illustration, this anvil-looking object. I'm still not sure how this gentleman is gripping this anvil with this grip, but you should get the point that we want to do that. And the reason why we want to do that is because we want to put into context what something means. I know often in cases that I do this sort of analysis for, I come up with a number of, let's say, 500 newtons, or let's say 125 pounds of load on the spine at whatever interest level, let's say L3, L4. And the question becomes, okay, well, I don't know what that means. Well, what it means is that if this person was lifting a 10-pound object, such as let's say, an Amazon package, the force in this posture would be maybe three, four, five times as much on that particular location. So it helps us kind of shed light on what those forces are, and it gives another dimension other than a clinical dimension, because clinicians are in the process or in the business of basically diagnosing and treating disease. It gives us a way to quantify that. And so, Dan, go ahead. Um, Specifically talking about injury biomechanics, I'm going to throw some terms around, and I kind of want us all to be familiar with. Please forgive my rudimentary depiction of a skeleton. This is stems from a time. I believe I created this during time of Halloween. I guess if you just wait long enough, it'll be in season again. But let's assume you have a fractured femur, and somebody's talking about your biomechanist is talking to you about a mechanism of injury. Basically, the question that we're asking is, how did the injury happen? Well, it happened through a blow to the knee. When your biomechanist is discussing tolerance, we're talking about how hard was that blow. And in this particular instance, you need over 2,200 pounds to create that type of injury. And the idea is that we would use this analysis to see if there was a mechanism possible in this scenario, right? We would see where would the force of 2,200 pounds even come from to so we could attribute the injury to that particular scenario. It's one way that we could keep the other side honest with respect to their narrative. Dan? Um, Diving a little bit further into other things we could discuss. So in injury biomechanics, we're basically talking about the study of the relationship between mechanical forces and injury. So I've already mentioned kind of the mechanism of injury and the tolerance, but there's other things we could talk about. We could talk about the injury severity. How injured are you? And we often talk about, I didn't go into it in this presentation, but we often talk about something called an AIS level injury, right? It's something where it's an abbreviated injury score. This is how us biomechanists quantify injury, and it ranges from 0 to 6. 0 is basically no injury, and 6 is unsurvivable. We also talk about likelihood. How likely are you to get this injury? And this kind of is something that attorneys love to have a conversation about because in the work that we're doing, the standard is more probable than not. So even if you have a case where you have a 10% chance of injury that's being claimed, it's still less likely than not. So the likelihood of injury is a really interesting way to tie that back to the legal standard. We also talk about injury prevention. So let's say you have a case and the questions center around, yeah, okay, we can't dispute liability. We know this individual is injured, but could we mount a seatbelt defense and say that this injury would have been very preventable had this person been wearing a seatbelt? Same thing goes for a helmet or even available railing that walking down the stairs, something like that. Dan? Um, some other questions you might ask as you're engaging with in talking with a biomechanist, and these are questions that I'm asking myself as I'm listening to you describe your case. Are the reported injuries consistent with the mechanical event? This is the sort of thing that I was mentioning earlier. We need a mechanism of injury. The other thing that I asked myself, what caused the injury? What caused these injuries, and also in what sequence did these injuries occur? That's probably even more important. In what sequence? Because there are times where the sequence doesn't make sense. And I think that's because the narrative isn't fully fleshed out from the other side, and it's somebody who is putting a narrative together that might not understand how physics work. Best example I can think of there is, you're getting rear-ended in let's say, a low-speed rear end, and they start discussing how they went forward. Well, that's not really how that works, right? When you get rear-ended, you remain still and the vehicle is accelerated around you. So you actually move rearward relative to your seat. And I already mentioned this next one. Could these injuries have been mitigated or reduced with some use of protective equipment such as restraints or a helmet? Dan? Um, Looking more at the kind of biomechanical application and in the automotive space, the first thing we would want to do is talk about accident reconstruction. And those of you guys that handle transportation cases, you're very well aware that we need some accident reconstruction first, so we can quantify the environment, right? We need to understand what is the delta V, what is the principal direction of force. And in more complex cases, we need, like, let's say you have a rollover. I've worked on many complex rollover cases. What are the roll rates? What are the discrete impacts, and so on. You need all of that before you start talking about injury tolerance, because um, that's something that you need. You need to know the environment first to be able to say, hey, injuries are possible. So in that spirit, I've actually gotten a certification from Northwestern to do accident reconstruction work. I do accident reconstruction work in the service of biomechanics, so I can handle both. Other things that we should quickly mention here, there's crash tests. Keep in mind, crash tests don't have to be the standard crash tests that you guys are familiar with from either federal motor vehicle standards or insurance dictated crash tests. They could be specific to your case, but it has to be justified by the exposure. Crash tests are very expensive. You're looking at probably spending six figures just on the test, not even counting the vehicles. But it's something you could do to investigate, plaintiff theory or whatever have you. A lot of that makes sense in product cases, transportation related products cases. There's also sled testing. Sled testing is a more straightforward way to do that. It's basically where you put vehicle components of interest, such as a seat or an airbag, onto a sled, and do you decelerate it, with a known crash pulse. But that is, you can do that cheaper and faster. You can probably run a couple a day, whereas you're probably only running one crash test a day. There's also component level testing. We can do dynamic or quasi-static testing. I've done a bunch of that work. There's also dummy testing. Dummy testing, I refer to it here as ATD testing, which is stands for anthropomorphic test device. But these are crash test dummies that we're all familiar with, and they aren't exclusive to the automotive space. I worked on cases where I was investigating head injury potential for a shower head dropping on a child's head, and saying that, okay, well, this caused a traumatic brain injury. I was able to show that no, those loads are way under the injury threshold, even for pediatric user. Another one that comes to mind is using it in a air mattress. There was a claim, products claim against an air mattress manufacturer that once the air mattress became deflated, you could sustain a back injury as you were rapidly deflated to the ground. And my testing was one of my favorite ones to as I think back over my career, because it took about 7 minutes for this test dummy to be lowered ever so slowly to the ground with absolutely minimal loading to the back. So it's actually different applications for dummy testing. Quick thing, Matimo modeling, Matimo simulations. That's the gold standard in the automotive space. We have the ability to do that. That allows us to do things a lot faster and a lot more rapidly. Also, surrogate testing. This is one where we would take somebody of the appropriate height and weight as let's say, the plaintiff, and we would put him in the environment that, let's say, in a vehicle. We would put him in a vehicle, and we would simply have them wear the seatbelt. Given where they are seated, we would then be allowed to examine exactly where on the restraint system we'd expect to see the evidence. And we could then go back to the original, the subject vehicle, and say, okay, well, if there's actually evidence there, then we can say something about whether they were belted or not. But this is a low tech but highly effective way to show these concepts in front of a jury. Dan? Um, should be no surprise here. Biomechanics has case law. It's been used in the past. I'm not going to go into the specifics here. If you guys really want some reading materials before you go to bed, we can forward this, and I'll have you guys review it on your own time. Dan? Um, this is the same sort of the same sort of thing here. There's some because this is CLE. There's some court rules that dictate experts in the state of Washington. I'm not gonna go into them here either. And with that, let's go talk about our case studies. I'm going to talk about these little more quickly because I don't want to run out of time. I do want to leave a little bit of time for questions. But essentially, um, this is what a modern seatbelt system looks like. Okay. It's a little bit different than grandma's old Buick that has just a lap belt. It's a sophisticated energy management device. It has an energy management loop. It has a buckle assembly and a tongue. Webbing is this material that you put basically against your body. There's a D-ring. There's a retractor with a web grabber. Newer versions even have a pretensioner. Super sophisticated. Go ahead, Dan. And we all are familiar with how that works. Basically, you can extract webbing. Go ahead, Dan. You can retract webbing, but once it's locked, you can't retract or extract webbing. So in a frontal impact crash, such as the one I show here, we have a scenario where the individual moves forward and loads the seat belt and actually makes it move across here in a very high force and with high force and high speed. Go ahead, Dan. So, in that, understanding those sort of principles, the way that I would look at if an occupant was belted, I would look at the restraint system, I would look at the vehicle compartment, as well as the evidence on the occupant. So when I'm talking to you guys about what materials I need, to the extent that the vehicle is available, I need to see the vehicle. Even if somebody else has done the inspection, let's say an adjuster or even another expert doing only accident reconstruction, I want to see the vehicle because I need to do my own inspection to be able to tell. Also, I want to see the medical records because I want to look at some things that are related to the evidence on the occupant. Go ahead, Dan. So, I think here's a frontal impact crash that I'm showing to kind of remind us what that looks like. And I hope with this being a stream, the frame rates is good enough for you to see here. What I want you to remember is that motor vehicle crashes are very violent events. We have a tremendous amount of energy, kinetic energy that's basically being input at the front end of a crash, and there's a lot of energy management that happens there. Here we see one at 40 miles per hour, two adult occupants in the front, two pediatric occupants in the rear, and a lot of things to consider when evaluating something like this. Now, let's talk about the restraint, which is the seatbelt. I'm going to be looking for typical witness marks, and I'm looking at the web-bearing surface of the latch plate. Go ahead and hit the next slide, please. What I'm be looking for is a melting of the polymers that are on top of the latch plate as the webbing comes across it at with very high force and very high speed. This plastic melts, and we can use this as evidence that somebody was actually belted. Go ahead. The similar thing is true for the D-ring, which is the part by your shoulder where you grab your seatbelt. Go ahead, Dan. And that is the same sort of or similar type of markings, but they're going to be at an angle because of the routing of the belt. Go ahead, Dan. There's some other things that I would look at, especially if we had a high impact, such as the 40-mile-an-hour crash I just showed. There would be witness marks on the D-ring, as well as the retractor mounting bracket and some other things. But you want your biomechanist that's evaluating restraint, you want them to conduct their own inspection. Go ahead. The other thing I would mention here is the last piece is the occupant. For those of you guys that are a little squeamish, I would give you just a warning here to maybe look away for a minute. Go ahead, Dan. I'll be looking at belt markings to the neck, the torso, and the lap belt. And this is one where we actually have photographs that were submitted to this file, but there are narratives and things in the meds that could be helpful. So again, the medical records, it's important that we get those. Go ahead, Dan.
Great. Thanks, Zdravko. All right, so we have a little bit of time left here. We'll try to keep us on time as I get through my case study. So mine's nighttime tractor trailer collision and specifically looking at critical stopping distance. So setting the scene here, late at night, 8:30 p.m., two-lane interstate highway, rural area, so not a ton of ambient lighting. Person X was driving a silver sedan, which became disabled in the roadway and was sitting in the left lane with no lights on. Person Y was driving a tractor trailer and collided with person X's sedan. Allegations in this case, person Y operated the tractor trailer in a careless and negligent manner. They failed to reduce vehicle speed and take evasive action in order to avoid the collision. And person Y failed to keep a proper lookout, resulting in the incident collision. So human factors analysis, what we're looking at here at each one of these levels, individual, environment, and product, looking at the attentive state of our operator, as well as offering a perception response time analysis. So how quickly should they have detected, identified, and responded to that silver sedan in the roadway? The environment here, talked a little bit about already, nighttime visibility. Again, the hazard itself is a stopped and unlit hazard or vehicle. And then the product itself, our tractor trailer and its headlight throw, and the tractor trailer's ability to stop. Um, so PRT sort of analysis here. PRT is made up of these three stages: detection of the hazard, their perception or identification of that hazard, and then the decision on their response. This is what makes up our actual PRT, and then the driver or vehicle response is what happens after that. In this sort of context, there's a lot of research that goes into this, a lot of literature I would be relying upon. But with all of the information we know here, and this is sort of like a high-level review for the context of this case study, but we were able to mark this at a 2 to 3 second PRT. So across 2 to 3 seconds, this tractor trailer driver is detecting the hazard, identifying it as something they need to respond to, and then making that decision. So, a little background here on where drivers need to look as they are attending to the driving task. There are a bunch of stimuli inside the vehicle, outside the vehicle, but somebody, again, who is alert and attentive to the task is doing all of the above in order to, again, safely operate their vehicle. Factors that can affect PRT. There are driver variables, as we've been discussing, their attention, their distraction, if any. Age certainly can affect one's PRT. The older you are, likelihood of having a higher PRT is there. Visual performance, again, expectancy. Is this hazard something that you might expect? Here in a, not well lit area of the interstate, while driving on the interstate, you don't necessarily expect to encounter stopped, disabled vehicles in your lane of travel. So that's something to consider as part of assigning an appropriate PRT. Again, number of response options considered, fatigue, experience, all things we'd want to look at before assigning the PRT. And then, of course, the environment plays a large role in that PRT range as well. And so, how conspicuous the hazard was, time of day, weather conditions, all things we want to take into consideration. So, a little bit more here on conspicuity. Basically, how noticeable something is, how much does it stand out? Depends on factors such as contrast, its size, brightness, movement, as well as its location relative to gaze. It's also relative to environments. So two examples here. We have this bright white sign, rather conspicuous based on its background. And then if you look closely, you'll see a person walking in that crosswalk. There's a lot going on in the environment. It's a little bit more difficult to discern right away. So something that might be considered inconspicuous. Driver expectations, again, is a big factor in determining an appropriate PRT. This was an example of a violation of one's expectations. Again, you don't expect to necessarily encounter a disabled, unlit vehicle in your lane of travel. Much harder to avoid in this sort of situation, especially when you're traveling at higher speeds, 65, 70 miles per hour plus. That's going to have an influence or an impact on our PRT. Collision avoidance behavior. So when an obstacle, such as a vehicle like we have here, poses as a potential hazard, typically drivers will engage in one of three responses. That's braking only, steering only, or a combination of those two. So here are some screenshots. Luckily, in this case, we had forward-facing dash cam footage. And so this sequence of slides here will kind of set the scene for what happened here. So our driver is starting here in the left lane. As they're driving, they decide, I believe they were just passing another slower moving vehicle. So now they're continuing to drive forward and move into the right lane and out of the passing lane. The tractor trailer ahead of them begins to brake. So their response was to move lanes and get over to the left in order to pass that slower moving tractor trailer driver for whatever reason they were braking. This is seconds. I believe this is 2 or 3 seconds before impact takes place. If you look, you can start to see debris in the roadway. And then this is about a half a second, I believe, before impact. You can see that the vehicle is fully illuminated in the headlight throw of the tractor trailer driver's headlamps. and then we have impact. So if you remember, there's really not a lot of options here available to our driver in terms of avoiding this collision. He risks going off the roadway if he were to steer to the left, which he eventually did do, and he can't necessarily go right in order to avoid because he has that other tractor trailer driver adjacent to him. So the analysis revealed that the distance needed to avoid this incident by braking was approximately 545 to 649 feet. This takes into consideration the headlight throw, the PRT, and the braking distance. So this was in collaboration with vehicle engineers as well, an accident reconstructionist that was able to provide some of these values as well. And so what was available to the driver based on their headlight throw, this was low beam setting as well as high beam setting, was 250 to 350 feet, which was just not enough distance and space in order for him to avoid this collision. So during the process of that 2 to 3 second PRT, the vehicle was traveling an additional 208 to 312 feet. That PRT ends. And then the vehicle response or the braking was another 337 feet. So this was not a situation that was, necessarily avoidable on behalf of person Y. Some of the conclusions we offered here, I apologize for going through this somewhat quickly, but the position of person X's vehicle and the lack of lighting decreased its conspicuity for approaching motorists, and that included person Y. An alert and attentive driver in the position of person Y simply didn't have enough time and distance in order to perceive, react to, and avoid the presence of person X's stalled and unlit vehicle in the roadway. All right, that wraps up our presentation. I know we're just a couple minutes past the hour. We're happy to take any questions that are out there. I don't know if we can access the Q&A.
Yeah, I just opened it
Thank
up.
you for
I don't see
attending.
any pending questions, but if there are any, please feel free to drop them in there. Obviously, we appreciate everybody's time, and as we're thinking about potential questions, I just wanted to remind everybody that our contact information is available if you'd like to reach out and discuss your case to see if and how we might be able to help. Feel free to do that. We worked with on all kinds of different cases, so we're hoping we can help you. And if we can't help you, we'll tell you.
Thanks, Dan. Thanks, Zdravko. Um, of course, and let's see if I can get this. Berlin.
For Lewin.
Very
Nice.
good.
Berlin.
Very good.
Okay, there we go. And all of our friends at Berlin. We hope to see more of you too. And this presentation was awesome. Very much appreciated. So if anybody wants, obviously you can find Berlin online, or you can always reach out to me at wdtl.org, and I will send you on to Dan and Zdravko.
Very good.
Great.
Okay, everybody have a great day. We will look forward to seeing you soon. Take care.
Thank you.